Hello everyone. Today we will talk about degree of freedom. It is an important topic for medical as well as engineering aspirants. It has some of its application in different chapters like thermodynamics and kinetic theory of gases. So let's start degree of freedom. Uh, for degree of freedom, first of all, what is degree of freedom? Degree of freedom is a way through which we get to know that how a molecule can rotate in an empty space like this. If we consider this as a molecule, so it can move along x-axis, y-axis, or z-axis. This is a single molecule. Then similarly we can take diatomic molecules or triatomic molecules. Triatomic molecules can be present in two forms, this and this. This is linear and this is non-linear. So these are the different types of molecules: monoatomic, diatomic, and triatomic. uh, One thing we get to read in vector, that if a body is present in x-axis and moving along x-axis, then its motion along x-axis will be completely independent from what is happening in y-axis. These box axes are at 90 degree, so if you take component of x-axis along y-axis, then we will get nothing. Means the component of x-axis along y-axis will be 0. Similarly, we start with molecules monoatomic molecules. These are those molecules which consist of single atoms, like we consider at helium, neon, and argon, many other gases. So for these molecules, degree of freedom is equals to 3, and it consists of only translational motion. Translational motion. So in case of degree of freedom, different molecules can have different types of motion. First of all, we talk about types of motion that a molecule can have. First one is translational, second one is rotational, third one is vibrational. So in case of monoatomic gases, only translational motion is seen. If we rotate a monoatomic molecules in an rotational way, like if we rotate it and keep it at the same place, then we cannot find whether it has been rotated or not, because it is very difficult to detect. So similar, in case of monoatomic molecules, there are only three types of three degree of freedom. So there is a formula through which we can find a degree of freedom. Degree of freedom of a molecules can also be found through a formula which is 3 into n minus b, where 3 is simply a constant, n is equal to number of molecules, number of atoms present in molecule, and b is equal to number of bonds. So in case of monoatomic molecules, we use this formula b 3 n minus b, then 3 into number of molecules for monoatomic gases is 1, minus there is no bond, so we get 3. So in case of monoatomic molecules, there are only three types of translational motion: one along x-axis, another along y-axis, and another along z-axis. So it can move along three axes. We talk about diatomic molecules. In diatomic molecules, this is an diatomic molecule present in, suppose we consider it as if it is present in x-axis. So a diatomic molecules can rotate along x-axis, y-axis, and z-axis. It can rotate through all three its axes. We talk about rotational motion, then we get to know that if this molecule is present along x-axis, it can rotate along y-axis and z-axis. Like if it is present along y-axis, then it can rotate along x-axis and z-axis. So for diatomic molecules, there are two types of motions which are present. One is translation. First is translational, and it is 3, one along x plus y plus z, and second one is rotational, and it is 2, one either of the axes. If the body is present in x-axis, it could be along y or z. If the body is present along y-axis, then it could be along z and x-axis. So for this it is 2. So total number of degree of freedom for diatomic molecules, degree of freedom for diatomic molecules is equal to 5, 3 for translational and 2 for rotational. Now we will talk about triatomic molecules. In case of triatomic molecules, it could be like CO2 and O3 or different gases. So triatomic molecules, there are two types. One is linear and one is non-linear. So first of all we will talk about linear, and then we will talk about non-linear. In case of linear molecules, we use this formula, then we get DOF is equal to 3N minus B. For triatomic molecules it is 3 into number of atoms 3 minus. In case of linear molecules we will get 2 bonds minus 2, we will get 7. But in case of, this is for linear. In case of non-linear we get 3 into 3 and 3 number of atoms minus. There are 3 bonds in non-linear molecules, 3 is equal to 6. So we get 2 results in case of triatomic molecules. So let's see. Suppose this is a molecule which is present in any of the axes, x axis, y axis and z axis. So it can rotate along first x, y, z. It will show 3 types. Triatomic molecules will show all 3 types of motions. This is the only case in which triatomic molecules can show vibration. See, first one will be translational, and it will be equals to 3. Second one is rotational, like if it is present in x-axis, similar case of diatomic molecules, it will show 2 of the rest remaining axes. Third one is vibrational, it will be equals to 1. This is the only case in which you get to see a vibrational motion of the molecules. So in case of triatomic molecules you get to see all 3 types of motion. So for DOF for triatomic molecules is equals to 6 for non-linears and 7 for linear molecules. One more thing, in different questions we get to read we get one thing, like if in any questions it is written that then they had not mentioned any of the gases, like they had not mentioned monoatomic, diatomic or triatomics, but they had simply told that there is a gas which is present in space. Then in that case you will consider that air, simply air, as diatomic molecule, because air consists of O2, N2, He and different gases. We know that nitrogen is present in 78%, then oxygen, then helium. So the diatomic gases have large amount in air. So we consider air as in diatomic molecules. In many questions they had not mentioned whether with diatomic talking about monoatomic or diatomic or triatomic, but they simply write air. Then in that case we will consider air as in diatomic molecules. One more thing which I would like to tell you, that if in any question it is given that there is a triatomic molecule, diatomic molecule and monoatomic molecule, and they taken the temperature to very high degree, then in that case if temperature increases to a very high degree, both triatomic and diatomic molecules will behave as monoatomic, because suppose this is a triatomic molecules. If you rise the temperature to a very high extent, then these all bonds will be broken and the molecules will get separated. So in at a very high temperature, all three molecules will behave as a monoatomic gases. So this is all about degree of freedom. If you want to know something more, you can comment below, and also you can ask me about anything, whatever you like to know. That's all. Thank you.